Hey everybody, let's just jump right into it. Chapter 2. All right. Starting off with some of the fundamentals, things you've probably heard before. Um, Matter, right? That's the fun one. So, what is matter? You're made of it. We are made of it. Everybody, everything in the universe is made of it. The difference is in this class, we're primarily going to talk about the matter that makes up living things, us. Right? So, but everything's made of matter. Matter is just literally anything that takes up a space and has a mass. If you want to think of it from the smallest level that we're going to get to, think of it from atoms. Okay? Elements, carbon, hydrogen, oxygen, nitrogen, right? The things that make you who you are, the things that you need. Calcium, that's going to be a huge one later on when we start talking about neurotransmitters and pathways, neural pathways, and how we create action potentials. Sodium, potassium, right? These are all things that are matter. Not only that, but if you are matter, you have a mass, right? And everything has a mass. There is a difference between mass and weight. The way I remember it is how you measure it, right? If I weigh your mass on Earth and then weigh your mass on the moon, the mass will be exactly the same. It doesn't matter where you are, wherever you are in the universe, your mass will remain the same. You're still made of the same components, right? However, your weight has to do with gravity and how it pulls you to the earth. Do you need to know this? Nah, I think it's fun. So weight is it can change depending on how much gravity is on you. Hence, if you go to the moon, you weigh less, but your matter and your mass stay the same. Fun things. Elements. All right, elements are a substance that cannot be broken down anymore. All right. I mean, if you want to get nitty gritty and be like, hey, they're made of proteins and protons and electrons. Yeah, I guess. But the bottom line is, if you are carbon, you can't be less than carbon, right? So carbon's carbon. You can't break it down any more than that. All right. Can you build things with carbon? Sure. You can make carbohydrates. Literally, carbo is in the name, carbon. You can make fats, so on and so forth. But an element is the individual building block. All right. Think of elements as Legos. One Lego. Can you take a whole bunch of individual Legos and put them together? Sure. That's how you make compounds. That's how you make molecules, right? That said, there are 92 naturally occurring elements, and the ones that we love are the ones I already talked about quickly: carbon, oxygen, hydrogen, and nitrogen. Those make up 96% of you. The other 4% of you are down here, right? So the calcium, phosphorus, so on and so forth. Um, there are also trace elements, and that's something people don't really think about. There are elements in your body that are so small you barely even, or really, look here, half the time you don't even, they're not even measurable. They're so small, right? They don't even come up in the grand scheme of things. Yeah, they're there. Yeah, you can measure them, but they're so minute that you don't even think about it. But without them, you would die. And there are ultra trace elements that are also very, very small in quantity, and you need them to live. But what's weird about it is if you have too much of these ultra trace elements, they can be toxic. An example is arsenic. Your body has arsenic in it. However, if you have too much of it, as you all know about arsenic, or many of you do know, it can kill you if you have too much arsenic in your body. Here is the same chart, just you can see it again, right? So here are the 99% of the elements in the body, and here are the trace elements that make up less than 0.1% of your body. Right? And life requires about 25 elements, and they are going to create different combinations, and that's huge. Okay? You don't just take, nitrogen and toss it in the body. You got to use it in something, make something. What can you make with nitrogen? I'll tell you, fun fact, proteins, right? But the point is, you're going to use these elements and make different things. Is there one, for example, nitrogen? You can make proteins. Is there one protein in the body? No. There are so many different types of proteins, and they all require nitrogen. So the point is, again, Lego blocks. Can you make things with the Lego blocks? Heck yeah. Are they always going to be the same structure? Absolutely not. All right. And that is the first section here, understanding matter and mass. And now we're going to talk about the atomic structure and how these elements actually behave in the next video.